guys, so for today what we're going to focus on is the factor theorem. Now the factor theorem is just an extension of the remainder theorem which you learned in the last lesson. And the factor theorem basically says that x minus a is a factor of the polynomial f of x if f of a is equal to 0. So basically, if the remainder of the division is 0, then that means we have a factor of the polynomial. So for example, if we have a situation where we have x squared plus 4x plus 4, well, you already know how to factor that without even using the remainder theorem. You can factor that using reverse FOIL, and you would know that this is x plus 2 times x plus 2. But just to check and make sure that the factor theorem is in fact true, what we can do is we can find out what a is. So in this case, a is x minus a equals x plus 2. So that means our a equals negative 2. If I plug my negative 2 into this equation, what I should end up with is something equal to 0, because that's what the factor theorem says. So let's do a quick check. If I do negative 2 squared plus 4 times negative 2 plus 4, that's the same as 4 minus 8 plus 4. That is indeed 0. Right? So the factor theorem is, again, just an extension of the remainder theorem. Okay, so let's take a look at a couple of examples of the factor theorem at work. Most commonly, the factor theorem is used to help us discover if a certain factor is actually a factor of a polynomial. So in this case, is x plus 1 a factor of 3x power 4 plus x power 3 minus x squared plus 3x plus 2? Well, you could do this the long way, and you could actually divide using long division or synthetic division, but a quicker way is to use the factor theorem. And if we find out a, right, remember a in this case, x minus a equals x plus 1, that means a is equal to negative 1. And if we plug in our a into our polynomial and it comes out 0, that means it is a factor. So this is a quick way to do it.
We're just going to plug in negative 1 into our polynomial, keeping in mind that when we get our a to the flip side, right? Plus 3 times negative 1 plus 2. Alright, negative 1 goes to the even power, we end up with 3. This is an odd power, so it's negative 1. This is an even power, so it's positive.
So 3, negative 3 cancel out. Negative 1, 2, they cancel out. This equals 0. Therefore, yes. It is a factor. All right, second one. Is x plus 1 a factor of x power 6 plus 2x times x minus 1 minus 4? Do the same thing, right? Our a equals negative 1. Let's plug negative 1 into this, and if we get 0, that means it is a factor.
Negative 1 power 6 plus 2 times negative 1 times negative 1 minus 1 minus 4. This becomes 1.
This is negative 2 times negative 1 is positive 2, and that is 4. This equals 1. Because it's not 0, no, not a factor. Okay, so in our fourth and final example, we're going to look at a slightly trickier question, and it's going to take a little bit of creative, critical thinking in order to solve this problem. We have an expression, we've got a polynomial, and it says that it's exactly divisible by x squared minus 2x minus 3. So what that means when we say exactly divisible by, we mean that this is a factor of this, okay? Is a factor of that guy. All right? And what we're trying to find here is the value of a and b. So again, because we're using the factor theorem, what we know is that if this divided into that should leave a remainder of 0. Excuse me. First thing I'm going to do is I'm going to factor this guy out. So I'm going to turn this into x, right, reverse FOIL, x, and it looks like it's going to be x minus 3 times x plus 1. All right? And that means in this case our a is 3, and that means in this case my a is negative 1. Now, according to the factor theorem, if this is a factor of this, that means if I put a into this equation for x, I should get equal to 0. Also, if I put negative 1 into this equation, it should also be equal to 0. Right? So, what I'm going to do is I'm going to create two equations to help us solve for these two unknowns. I think it's a little bit confusing that I use the variable a here, but when I say a, I mean the xa, right? Not the a over here. So let's look at this. I'm going to have a times 3 to the power 3 minus 8 times 3 squared plus b times 3 plus 6.
That's going to be 27a minus 9 times 72 plus 3b plus 6. That becomes 27a plus 3b.
Minus 66. And we know that this must equal 0. Let's simplify this down a little bit by adding the 66 over to this side and dividing everything by 3. So this becomes 9a plus b equals 22. All right, so there's my first equation. By plugging in x equals 3. Let's try and create the second equation by plugging in for x equals negative 1. Again, remembering that when I plug in x equals negative 1, this whole thing should equal 0. Right? So, a times negative 1 power 3 minus 8 times negative 1 power 2 plus b times negative 1 plus 6. Again, this whole thing equals 0, just like we did over there. This becomes negative a. This is positive, so that becomes negative 8. This is negative minus b. This is plus 6 equals 0. This becomes negative a minus b minus 2 equals 0. Let's try and make these a's positive by moving them to the other side. So we'll end up with a plus b equals negative 2. And there we have our second equation. From there we have a system of two equations and two unknowns. So, like simultaneous equations, we can do a quick elimination here. Maybe I'll subtract my a plus b over here. And when I do that, I will end up with 8a equals 24. So that means a equals 3. And then once I have my a equals 3, let's plug back into this guy. 3 plus b equals negative 2, so that means b equals negative 5. And there we have it. Our b is negative 5, our a is 3. So again, the key to this is using the factor theorem, understanding that this breaks down into two different pieces, and coming up with a way to create two equations to help us solve for our two unknowns. Okay guys, so here's the practice problem for tonight. Determine whether each of the following is a factor of the expression 3x cubed plus 2x squared minus 7x plus 2. So for each of these A, B, and C answers, you're going to want to give me a yes or no answer. Quick reminder, to find A, we simply set each of these equations to 0. So for example, x minus 1 equals 0. In the first one, our A is 1. And then to use the factor theorem, we're going to take that 1 and I'll plug that back into this equation. For the last guy, what we're going to want to do is factor them out into two different binomials and then take those two binomials and check that each of those binomials does work for this equation and make it equal to 0. All right? I'll see you guys tomorrow.